Today, we're gonna see how phones are made. I'm here at the main manufacturing facility of OPPO outside of Shenzhen, China. And we're gonna get to see a lot of the details that go into making a state-of-the-art flagship smartphone. I've been making videos about phones here in China for almost 10 years, ever since I made my own phone from parts that I bought in the markets of Huaxiang Bay. And so getting to see inside a real smartphone factory for the first time feels like I'm coming full circle. I'm headed to go meet the head of manufacturing, and he doesn't speak that much English, and I don't speak enough Mandarin. So we're gonna be wearing these radio earpieces so that we can hear a professional translator doing simultaneous translation as we're talking. Hi, I'm Scotty.
我是单，我是制造部的负责人。
Awesome. I'm super excited to be here. Thank you for sponsoring me and my team to come out here and for giving us such complete access to the factory. What are we going to go see first?
想带领介绍一下我们的 SMT 工厂。
Awesome. Let's go check it out.
OK，
Where are we right now?
我们现在在我们 OPPO 最大的生产基地，这是我们的整个手机的贴片。今天我们做我们的方案的 X9 系列的整个主板的生产，这是我们整个的一个叠板技术，分为了3个板。
Amazing. So 3 layers here, 3 separate PCBs?
是的。
Okay. What does the logic board do? What does the main board do?
手机主板的整个功能它像人的大脑一样，来驱动整个手机的运行。
Right. So it has the CPU. It has pretty much all of the integrated circuits.
对。
This one has it has all of the connectors for the screen. This one has the camera modules integrated into it. It's like the most important part of the phone, maybe.
是的。
Yeah.
这是我们的整个方案的 X9 系列的一个主板，整个主板采用了一个磁悬堆叠技术，将我们的多个摄像头以及我们的激光对焦 IC 集中在我们的整个deco 区域，我们的2块板几乎一模一样，这是提高了我们的整个的空间利用率，就是这一代比上一代我们的整个利用率提高了大概13%。
What kind of efficiency? The power efficiency?
整个的我们的空间布局的密度。
Why is that important? Usually it's because you end up using that space for something else,
因
right?
为我们是为了确保我们整个手机的轻薄，对，还有功能的强大。
Okay, so thinness. Yeah, okay. And does that also allow you to increase the size of the battery if you make this smaller?
是的。
Yeah, okay. Because that's what everybody wants, is they want their phone to last longer, but they want it to have as much features as possible. And so if you could shrink the features,
对。
you can add more battery.
更长的，对，
Yeah.
更长的续航时间。
Can we take apart the 3 layers of boards to see what's underneath? Is that possible on this?
可以。
Oh, wow. This is very different.
对，这是我们的中间的一块板子，就这样整个的堆叠起来。
Got
对
it.
整个
Okay.
的堆叠起来。
This is like the connector layers, like a riser almost, to create space between the bottom board and the top board, which then has more ICs on it. And then you solder these together to make a sandwich.
对，我们的大概就是这样子，就是一个三明治一样。对。
Yeah.
像一个三明治一样。
This is amazing.
Yeah.
Why do you stack the boards like this? Why not just make one board?
这是为了提高我们的整个主板的空间利用率，还有和整机的一个匹配。
So it allows you to fit more in a smaller area, because now you can put, instead of 1 side, 2 side of ICs, you actually have 4 sides of ICs in the same space, in the same XY space.
对。
Yeah, very smart. This is super cool. Mr. Sean's a busy guy, so he's gonna head off to some meetings, but we'll catch up with him later in the final assembly process for some of the more unique things they're doing to put the phone together. In the meantime, I'm gonna explain to you the entire SMT line. There are some R&D engineers actually right behind the camera. We've been doing a lot of talking. They're making sure that everything I say is correct. There are a lot of screens in this factory, some of which have some confidential information on them. So I've just asked OPPO to turn those screens off so we don't have to worry about it. Let's head on to the first step. This is the very start of the SMT line for soldering the logic boards. They start as a panel of 4 separate logic boards. There's a stack in here that gets loaded onto carrier trays, which are just like a jig that holds the panel of boards and is very rigid so that as they're doing various things to the boards, they don't bend or warp or anything like that. These circuit boards or PCBs are made by a separate factory and then come here as they start down the line to have all the components put on them. So next they come here to this little machine, which they said actually cleans off any dust and surface contaminants, so the board is super clean. Coming into the solder paste machine. The solder paste is little tiny microscopic balls of solder suspended in a paste, almost like a silk screen process. It's a stainless steel stencil. They use a laser to cut out tiny, very precise holes for where they want to put solder. And then they literally just squeegee it onto the board. And that solder paste is where the components are going to be mounted a little bit further down the line, and then they'll melt it. Next, they do solder paste inspection, SPI. SPI is making sure that the solder is everywhere it should be and that it is aligned precisely with the board. They have a closed loop between their SPI machine and their solder paste stencil machine that is looking for misalignment where the stencil is slightly misaligned with the PCB and the solder paste is being printed slightly off in one direction, and it can actually automatically adjust, which is mind-blowing. Usually that's just dialed in by hand. So we've got SPI here. This is an optical process. It's using colored lights and a camera to see exactly where the solder paste is. It's pretty hard for us to see inside some of these machines because the covers are so dark and we're not able to open them while they're operating. Next, this is a buffer. It will remove and store any panels that have errors in the solder paste inspection and hold them off to the side for NG, no good. Next, we get into the pick and place machine. So this is really like one of the key pieces of the whole process. This is where all of the parts are put on the board, and they're all loaded off these reels. So they start from the smallest component, which is also the fastest machine. I believe Mr. Sean said they can place these 2 per second.
在于我们在一个极小的空间内要布大概1900个元器件。
And there are tiny components on here.
对对对，最小的规格是0.4乘以0.2毫米，已经达到。
So 01005 components.
对
Yeah,
对对对。
which is like, just so you understand, 01005 is a component that is so small, it is very hard to manipulate with tweezers by a human, even under a microscope. It is microscopically small. It's a little bit bigger than a hair. It is so small. I can barely see some of these with my eyes. And you can place them very precisely. Oh, you have some.
对，这是我们的。
Oh my
这是
God.
我们的这种器件最小的程度。
It like fits in the groove of my fingertip, of my fingerprint. These machines are exceptionally hard to see into. Normally when we see a pick and place on an SMT line, it's a bigger open frame and you can see inside. We're actually gonna show some footage of that from a previous factory that we've been to. They start from the smallest one and they're picking it up with a little suction needle. They're using cameras for alignment to figure out precisely exactly where the board is, but also precisely where the component is to go pick it up, but also once they pick it up to get the exact positioning of where it is on the needle tip. Yeah, we're getting into much bigger components now, stuff that I can actually see with my eye. The last machine is where they're placing the larger ICs, so like the processor, the baseband chip. This is also the more expensive components. The stuff we started at the beginning, it's like tiny resistors and capacitors. Now we're getting into like actual dollars per component or more. Then we're getting into another visual inspection machine. So this is a AOI, automatic optical inspection machine. It's using a camera and a light, and it's looking for where each individual component is and making sure that it wasn't misplaced, that it's not standing up, that there aren't any missing components. Like the pick and place machine failed to pick one up and thought it put it down, but it didn't. Next is another set of pick and place machines, and these are putting on various metal shields that go over components that they want to have already inspected. And then we get to that stacking board. And this amazes me because they're using a pick and place machine to place that. I've never seen anything nearly this big being picked up by a pick and place machine. I asked them to provide me the custom suction head they use to pick up this part. This has 3 separate suction heads, and they have designed this together with the part so that it can come in and correctly pick it up and place it. And of course, this thing has to be super, super accurate. I've actually got an example, one of those top boards. It comes in like this. That is quite cool. Talk about detailed. I wonder how many people it took to perfect this and design this custom thing. Next, they're putting a jig on top of the stacked boards. It holds it in place and applies a little bit of pressure as it goes into the reflow oven. So the reflow oven is what actually melts the solder. And this one's special. This one is purged with nitrogen to push out all of the oxygen. There's only a tiny, tiny bit of oxygen in there. And that's to make sure that none of either the board, the parts, or the solder gets oxidized during the reflow process. So reflow ovens, typically they have different zones along the reflow oven. So it goes from all the way here, all the way to the end of this metal machine. And it's sort of like a conveyor belt toaster oven you see at the hotel for running your toast through, but it's got a bunch of different heat zones. It'll start out at a really pretty low temperature, and it'll bring it up to just below the temperature that the solder will melt at. And then right at the end, it spikes it up above the temperature needed to melt the solder, and then brings it back down pretty quickly. The reason for that is that some of the components are pretty sensitive to temperature, and you don't want to leave them at the high temperature for very long. This machine then removes that top fixture, and we go into another AOI machine, the automatic optical inspection, to do kind of the same checks that we did on the previous one. Are the components all in the right place? Are any tombstoning where they stand up on end and look like a tombstone in a graveyard? Is anything missing? Are there any connections between two solder pads that shouldn't be connected that's going to cause a short? The previous one was making sure that the pick and place process was correct, but this one is making sure that nothing changed during the reflow process when the solder started melting. And again, like we've had before, every time we have an inspection machine, we have a NG buffer, which removes those no good boards and puts them off to the side when they hit them. They have a 99.8% acceptance rate, which means their failures are below 0.2%, which is, that is next level. There's something I haven't really been explaining thus far, which is that this SMT line is actually doing both the top side of the board and the bottom side of the board. This front line here is the bottom side, and this robot is coming and picking up the carrier tray of all of the boards that have just the top side finished, and it will bring it back to the beginning of the line. The boards on the far side are the ones that have had the bottom side done and that stacked board put on top, and they need to continue on down the line. So they go through this bridge here with an elevator that lifts it up over the top, and the problem this is solving is that the robots need to be able to get through. So it goes up, over, and then down, and continues on down the line. Next, they're preparing the boards to be cut out of that panel. So there's 4 boards to a panel. We're gonna separate them. So it's taking it off the carrier tray that was used for soldering and going through the reflow oven, and it's putting it on another carrier tray, but this time for this depaneling machine, which is really just a CNC router that's cutting around the outline of the PCB with a little milling bit, like a drill bit, basically. It's got it on the carrier tray. It's got a top plate on top, and that's just to hold everything in place, make sure it doesn't get damaged. But you can see the head coming in and doing the cutting. By the time the boards come out of there, they're still in the orientation of the 4 boards from the panel, but they're individual. So there's a suction head that's just lifting them from there onto yet another carrier tray design. And this carrier tray is specifically for testing. So these big round machines with the robot arm in the middle, these are picking those boards up and putting them in various test fixtures. This first machine is loading the software onto the phone, right? So this is the operating system that the user sees, but first they're putting it into a test mode so that they can run a whole bunch of different tests that use software both on the logic board and all of this machinery, all of these pieces of test equipment. Once the software's loaded, it comes here to 2 separate calibration tests. It's calibrating all of the different radios on the phone. So cellular, Wi-Fi, Bluetooth, and so on. Making sure that the signal strengths that are coming out are correct, frequencies that are coming out are correct. This comprehensive test is then testing that those radios are operating properly, they were calibrated properly, It's also testing a bunch of other functionality on the board, making sure the chips are working properly. This is specifically testing Wi-Fi. And then lastly, they call this their electricity test. It's testing current on the board, how much current is flowing through different parts of the board. And this is an electrical test to kind of re-verify what happened at the AOI, the automatic optical inspection, to make sure there are no shorts between solder pads or that there are no components that are bad for some reason and are using more power than they should. And this really helps ensure the life of the phone. So yet again, we're switching carrier trays from the testing carrier tray now to a carrier tray to do adhesives. And this is the last one. This here is an oven to bake out any moisture that's gotten into the board since the start of the line. The testing takes a while. Sometimes the line gets paused. You really want to make sure the board's as dry as possible before you start putting on adhesives. Here is the start of the adhesive line. First, we're starting with an encapsulation, not quite a conformal coat, but it's a covering, and it's providing waterproofing and it's help holding smaller chips in place. Further down, they're doing underfill. For the bigger chips like the CPU and the baseband chip, they have little tiny solder pads underneath as like a grid underneath the chip. It's pretty easy for those to get damaged if the phone drops. It's possible for those solder pads either to rip off the PCB itself or to break that solder joint. And so the underfill is like an epoxy, a glue that they put alongside the chip, and it flows underneath and it just holds that BGA chip down to protect the solder balls. This dramatically helps the quality of the phone in adverse conditions, but it also makes the life of repair people hard. The repair techs have all sorts of special techniques to try and deal with the underfill because it can be so strong holding that CPU on. And then comes here to a UV light that starts to activate that glue, and then into a curing oven. And this is very similar to the reflow oven that melts the solder. One of the things I've noticed here is how automated this is. There are no spots on the entire line where there's a human touching every single board. They have 5 people per line, and they're really only here to load more components and then deal with any issues that come up on the line. They've got everything handled by the automated machines and the robots that are moving stuff around. Super cool. How many PCBs can one SMT line produce in a day?
我们的 UPH 大概是400，就是1个小时做400台。
400 an hour.
Yeah.
Wow. And do you run 24 hours a day?
是的，是的。
Oh my God.
一天接近1万 piece。
And then the last stage of dispensing is for thermal paste. There's 2 separate pieces here. One is dispensing it on top of the CPU and the baseband chips, which use the most power in the phone and can get quite hot. So they want a way to dissipate that heat. And the thermal paste provides a layer of conductivity, heat conductivity, to draw that heat out of the chips and into other parts of the phone so that it can dissipate. This part is wild. I didn't even know this existed. When you sandwich those 2 boards together, so you've got that stack up of 3 boards, you've got the 2 outer boards, and then you've got a cavity in between them. They're putting thermal paste inside that cavity. So they're injecting it like you would inject like a jelly donut. They've got a nozzle that comes in and there's a hole, and they're squirting it in there so that they can get good thermal conductivity around the chips on the inside of the sandwich. Mind-blowing. And then finally here is the auxiliary pieces. So it's little stickers and foil covers. Some of these are for like RF shielding, little pieces of foam to protect things. This is where you get into like the really fine details. I've been joking with the engineer that they're making the boards pretty by putting stickers on them. It's not for that. And then finally, they go into these plastic carriers to be sent over to the final assembly line. So let's head over there and see how they assemble the entire phone. You gotta watch out for robots here. So where are we now?
我们在我们发现的 X9 的组装产线，组装线就是把我们的刚才看到的手机的主板、屏幕、电池，还有我们的电池盖进行了一个组装，然后进行一个测试，做成一台完整的一台手机。对，我们整个屏幕的检测，还有我们屏幕和中框的一个组装。
And you guys are doing something very special on this model for the screen.
我们为了确保整个屏幕的显示面积，我们采用了整个 LiPo 技术，然后我们整个 COP 区域采用了我们的一个独有的灌胶技术，来确保我们整个这种线路的整个完整性，防止它损坏。其中的 COP 采用的这种胶水，是我们和厂家特殊定制的，它具有一定的特点，比如说防护性，还有流动性等等。
This screen has a very thin bezel around the outside. It's very, very close to the
是
edge.
的，是很窄，现在是1.15毫米，达到了行业最窄。
Oh my God, that's so thin.
是的，是的，是的。
So you mentioned COP. It's a basic technology for screen manufacturing. A lot of screens are made this way. So we have the screen itself here, right? And the OLED. What is this part here?
这整个的区域，首先我们有一个连接作用，确保我们的屏幕和我们的主板电池连接。然后我们中间有很多的这种 IC， 它的主要作用就是我们整个屏幕的显示，以及我们的一个这种超声波指纹的一些功能。
Got it. And all of this is on FPC board, right? Which is a flexible circuit board.
对，
So it's attached to a flexible circuit board, and then that board, how does that attach to the screen?
我们的整个 FPC 通过我们的线路连接到这个中间的，我们的线路在这两个屏幕中间，然后中间线路通过这种 FPC 把它给弯折进去，然后这里再通过我们的灌胶技术进行一个固定，来确保它们的品质，来进行起到一个防护。
Now,
对对。
you're doing something very special here to protect a problem that happens in screens sometimes and is even more a risk because of the thin edge, right? There's a problem here where this can get broken if you drop the phone on that bend, right?
是的，这个我们也是了解了这种消费者的痛点，以及它经常断。我们通过我们精密的模具将屏放在那里，然后将在真空的情况下将胶水灌充进去。
So basically, it's like an injection molding process that goes over the top of the edge of the screen with a plastic. You're getting it all through the cable to protect that cable inside sort of a plastic case that you're building.
是，在真空的状况下进行了这个胶水的注入。
Oh, under the vacuum. Okay, and then that sucks it into the middle.
对。
Got it. Okay, that is super cool. This is so smart.
这也是我们 OPPO 一直追求的，质量在于细节。我们一直把质量放在我们的首位。
Yeah, awesome. You guys are doing so many little things. This is so cool. We're gonna let Mr. Sean go off to some meetings, but we're gonna dive into the final assembly process here. This is the first step of the screens coming into the assembly process. They're just checking in the barcodes. She's doing visual inspection, making sure there's no cracks or dust or anything. Over on this side, they're bringing in the mid-frame here, the case of the phone. They're installing the snap key, which is a touch-sensitive button for the camera. So it's the trigger button for the camera, but also you can slide your finger on it to switch modes and which camera and things like that. So now we've got the two lines here running together. We've got screens on this side, mid-frames on this side, the body of the phone. He's applying a little protective piece of plastic to the bottom part of the screen and loading it into this machine, which applies glue very precisely around the outer edge of the screen, so it can be mated with the mid-frame a little bit further down the line. The screens then come here where they're blasting them with plasma, which is wild. I've heard of this before, I've never actually seen it. Plasma is super high voltage. They're also using a blast of nitrogen to blast it out. It's often what you see around super high voltage like lightning. I have heard, but now we're seeing that plasma, if you blast a surface with plasma, it actually makes glue stick better. So they're actually blasting the glue that they put on in the previous step to activate it and make it stick really, really well to that mid-frame. They also said it has the nice side benefit of blowing away any dust and other particulate from the screen to make it super clean for when they're gonna mate it with the mid-frame. And the reason they're so particular about this is they want it to be as waterproof as possible. So you really want that seal to be super strong and to not have any contaminants in it all the way around. This is one of the weirder jobs in this factory, and this guy isn't locked in the box because he's been bad or anything. This is actually like a little miniature clean room. They've got an air filter on top. He's got an ionizing air blower here. Actually, a lot of the stations have these. His job's relatively trivial. He's taking a sticker off the hole where the front camera goes on the front of the screen. They're putting him here because they don't want any dust to get in between the front camera and the front of the screen, or the back side of the screen, because it would show up on the front camera. And so he's removing it, sticking it into this machine, And they're just doing it in a very clean environment. So this is quite like a complex setup for something that's very simple, but it's to make sure that every single phone is perfect. So this machine is where the screen and the mid-frame come together. They're actually doing something a little bit complicated here rather than just pressing it straight on. There's actually a little bit of a curve on the bottom side of the bottom edge of the mid-frame. And so they're taking the bottom edge of the screen and slotting it in at an angle and then tilting it down. Rather than just putting it straight on, it would destroy that bottom edge of the screen. It's all about the details here. On the far side there, they're using a laser scanner to scan in 3 dimensions the mid-frame so they know exactly where it is so they can slide that screen in just perfectly. The robot arm now takes the mid-frame and screen and is loading them in a jig, like a top and bottom jig, that's pressing them together, and it's stored back in the machine here to let that glue cure for 3 hours. And then the suction cups here unload it at the end of the 3 hours and send it on down the line. Here they're testing to see whether that bond between the mid-frame and the screen is actually watertight. This model of phone is not only IP68, which is waterproof to 30 feet, it's actually IP69, which is the first time I've seen this on any phone. 9 is high pressure water jets with hot water, not just room temperature water. Now, how do you test if a phone is waterproof for every single phone without destroying it? You don't want to dunk everyone in water. Well, if it's airtight, then it's also waterproof. So they've got this machine that squeezes this jig down and it seals the back side of the phone, the other side from the screen. And then they essentially inflate it with compressed air. And if no air leaks out, then they know that that screen and mid-frame bond is going to be waterproof. This guy's job here is to put in the actual logic board, the motherboard of the phone. It starts with this machine putting down some glue, and then he puts in the board. And then this machine here is an automatic screw machine. It puts in just one screw that holds the board in place. And then further down the line, they put in a bunch more screws. Now they're adding all the various other parts inside the phone. So this guy here is adding the bottom circuit board that has charging port on it. I think it has like the speaker, microphone, things like that. Down here, they're actually putting in the cable that goes between that bottom board and the motherboard. And there's a lot of presses here. So what's interesting is when you repair a phone, you just push that connector down by yourself. But every single time they attach a connector, there's a machine that pushes it down and makes sure that it's exactly the right pressure. This is an antenna cable that's getting pushed in. There's actually 2 pins that are coming down and compressing each side, pushing it into the socket. Here we're doing one of the back cameras, and here is a second one of the back cameras. This side here is the line preparing the telephoto camera to go in the phone, and this is super interesting. This is a periscope module, so they actually bounce the image from the lens here to the sensor, which is way down at the bottom, and that's to create more space, more distance between the lens and the image sensor, which is just that blows me away. So next we're putting the speaker in the bottom part of the phone above that bottom board that has the charging port, plugging in cables, lots of plugging in cables with cable pressing machines. They're putting the macro camera in now, which is this little yellow ringed camera. And then here is a much bigger screw machine, and they're starting to put screws in that bottom end of the phone around the charging port and the speaker. Screws here, all camera aligned. This is very cool. There's a screen I can't show you that shows how it's aligning. So it uses a camera to align off of a screw hole on the case to know exactly where the phone is. And then it's also using a camera to pick up the screw exactly. And then here, they're actually doing some electrical testing. So this is the first electrical test on the line, and they're testing current. So they're making sure there are no shorts in any of the things that have been installed thus far, and making sure it's not using too much power. And now we're heading into battery land. So this machine is installing protective foam that protects the battery from hitting the edges of the phone, anything that would cause the battery be damaged when it's dropped or something like that. And here's where the battery is actually being put into the phone. He's just putting them in by hand. And then this machine is pressing them down to make sure that the glue that holds the battery in is well adhered. And then these 3 machines, 1, 2, 3, are inserting all of the screws into the motherboard, the logic board, that like top half of the phone. Each machine is doing a different set of screws. in this area, these 3 machines are applying glue in preparation to put the back on the phone. We're getting to the end of the assembly process. There's a large clean room here that has, I don't know, 10, 15 guys in it. And there's 2 sides to the line. In front here is the phones, and in the back is that back cover. They're doing a lot of cleaning and inspecting the camera lenses and making sure there's no dust in anything. As we move down here, this guy is taking the phone and the back, and this machine is picking them up and pressing them together. Doing some final testing here, final inspection. We get higher pressure now to start to activate that glue. And then finally, like we saw on the screen, they go into a press for an hour. Same deal where they've got a fixture top and bottom, it clips on. It goes into this big stack up back here for an hour, and then they pull it out at the end. And by the time it comes out here, we've essentially got a finished phone. But there's still a lot of work to do. This whole side here, everything we've walked down thus far, this side is just as long, and we get into testing and packing. One of the most important tests that they do is the burn-in process. So the phones come into these cabinets, and they get plugged in for 8 hours, and all sorts of things are going on. The screens are turning different colors, they're charging off of here, they're making sure that as the phone is running for the 8 hours, that no problems crop up. The initial first hours that any device is being used is the most likely time that you're going to have problems. And they want to make sure that it happens here in the factory and not the first few hours that someone gets their brand new phone. And there's a ton of these cabinets that are all doing aging down the line here. We got vibration testing here. This thing's doing visual inspection on the cameras. So the space between the camera and the outer glass to make sure there are no little specks of dust, little hairs, pieces of lint, anything like that. They've got testing software running on the phone. So every phone now has like a QR code and debug information about the phone so they can track it through the rest of the process. These machines are pretty cool. So we talked about that snap key button, and they've got a quick action button as well that's got that pressure sensitivity. And this machine is simulating a finger, and it's tapping on 5 different pressure points along those buttons to make sure that they're sensitive along the whole length of the button. So they've essentially got like a little probe that's coming in there and simulating a finger. Then we get into real testing land. So there's a huge row of machines that go down this way. So this one is testing the flashlight. And they've got little test jigs in here. It looks like this one can accommodate 4 phones at a time. Kind of pick them up, put them down, do the test. This one is doing SIM card insertion. So they have like a simulated SIM card that gets stuck in the slot, making sure they can read the SIM card. Down here is wireless charging. So as we go down the line here, we're starting to do camera tests and calibration, optical sensors. This is quite cool. They're calibrating the vibration motor. This is for the OIS for the cameras, so optical image stabilization. It's where the camera is actually moving the sensor to compensate for shaking the phone. They've got 2 of them, one for each of the cameras that has OIS. So Mr. Sean, what part of the process are we at now?
这是我们的一个 DIMRA 设备。对，这就是说我们进行对屏幕的一个2次校准。其实屏幕来的时候，在厂家已经进行了第1次校准，不过第1次校准是通用的一个校准。但是为什么我们进行2次校准呢？是因为我们的屏幕和我们的主板配合的时候，有兼容性的可能会一些细小的问题。我们为了让我们的屏幕和我们的主板和我们的 CPU 进行
OK。
对，进行一个更加达至更好的显示效果。
Once it's fully assembled.
是的。
What is Mura and why are we correcting it?
首先 Mura 就是缺陷的意思，就证明我们整个屏幕上面有的显示的缺陷，所以它叫 Mura。我们做2次 DIMRA 就是消除这些缺陷，对，然后让一块屏显示一个通透的屏。
If I understand correctly, the issue with Mura is that when you have an OLED screen, not all the pixels are the same brightness or the same color. And so you might have a color shift across the screen where it's one color up here and it's one color down here, or you have a brightness shift across the screen. Is that right? And then demura is the process of correcting for that in the IC. Is that right? So when we talk about doing the Jimura, when this is a white screen, that it's the even whiteness across the whole screen, same brightness, same color.
对。
And so how does this process work? Like you have this machine that we can't see very much inside. What's going on inside it?
其实我们这一块屏它分为上百万个采集点、屏幕显示点，然后上百万个屏幕闪现点之后，我们进行了一一的进行采集，来和我们的标准值进行一个比对，来看到我们有和标准值有差异的地方，我们进行了算法的一个写入，确保我们一块屏它整个显示是一个完整通透的。
Got it. Okay, and so basically inside of here, there's like a fancy camera that can see every single little pixel.
是的，有一个高清的摄像头来监控上百万个监控点。
Got it. Okay, so it's maybe almost like a microscope camera that can look individually at every pixel.
是的。
Got it. Okay, and then you can just balance the brightness. When you tell a pixel to be a certain brightness, you might make it a little bit more or a little bit less than other pixels.
是的。
That's awesome. This is very cool. Yeah. Very cool.
Okay.
Awesome. We're at the final stage of the process, packing. We're inside the packing clean room to make sure that no dust or lint or anything ends up in the packaging. The first step here is removing the test software. It turns out they only load the very base of the operating system over on the SMT line. Here they're putting the rest of the operating system on, apps and things like that. They're leaving the configuration though from all of the calibration that's happened up until now. Then it comes here and there's 3 steps of inspection. So this one's inspecting that the sticker that's on it that has an IMEI number, which is like the serial number of the phone, that the sticker IMEI matches what's actually programmed into the phone. This one's doing some software tests, making sure the versions of the software and everything is right. And then this one is checking that sticker again, making sure that the model of the phone is on there correctly, the camera lenses are all there, that the buttons are all there, just doing those last visual inspections before the phone gets packed in a box. This is where they start putting the phones in the actual packaging. So the boxes from the box factory are here, and they're starting to put the various accessories in. So silicone phone cases, a SIM card remover tool, charging cables here. And then this is the moment that that phone gets placed in the box. Manuals get stuck in here, and he closes the box, and then it gets shrink wrapped and run through an oven to shrink the shrink wrap onto the box, make it all nice and tight. And then finally, down here, they do one last visual inspection of the box itself to make sure that it's the right box, that it looks good, everything's where it should be. And then he scans the barcode and sticks it in a cardboard box with a whole bunch of other boxes. And finally, the finished box gets put in a cardboard box to be sent out either to a retail store or to the warehouse. And this is what you end up buying. There it is, the Find X9 Pro. I'm blown away by seeing this entire manufacturing process. There are just so many details that go into making a quality phone like this. So cool. Thank you so much for having me. This is just incredible to get to see. Thank you.
谢谢你的到来。
I wanted to thank OPPO once again for sponsoring this video. I was just blown away by everything that goes into making one of their phones and how much attention to detail you have to have. If you'd like to learn more about their phones or buy one of your own, click on the link down in the description to go to the OPPO website. I'll see you again soon.